Right now, everybody is interested in using them. There's a lot of rules and regulations and heights and all these things. So we'll try to make a little bit of sense out of all that and hopefully help you guys to make some informed decisions when you choose whether or not to use one of these devices for the jobs that you do. So we're going to talk about drones. Introduce the concept of unmanned aerial systems, or UAS, that's the technical term. A little bit about the current state of regulation, various capabilities of the commercial units that are out there, like the ones that we use. We have a few of our units that we have in our small fleet in the lab here. We'll fly one, maybe, we'll see, hopefully not chop anybody's head off or something. How to choose an appropriate one for the applications that you have in mind, and how you integrate these into your operations, and various applications that you can perform today in job sites, as long as you have the appropriate personnel and you meet the appropriate, or you meet the current regulations, which are changing constantly. And for us, we were trying to keep up with all the changes every day, and it's almost a full-time job to do that, as you may have heard in the news. So why do we look at this technology for potential applications and how they can help us do many things more efficiently, better? There's a lot of opportunities. There's our very large numbers of infrastructure. 517,000 miles of high voltage lines, and those lines have to be inspected. Imagine you having to have those people driving the truck under the line and climbing up the towers and looking at the towers and the wires and all that. You can do that with UAS right now. 200,000 cell towers. You have to get people there, put them in man buckets, up and do something to inspect or fix. You can do that with drones. 61,000 wind turbines, and that number keeps going up and up as we pursue more renewable energy. 2.5 million miles of pipeline, with many more miles in the drawing board. So imagine having to inspect all those things and have to access in very remote locations. Other opportunities, 100,000 mines and quarries around the world. This is something that many countries are looking at, and mining companies are looking at, to be able to measure, quantify, and track the progress of their mining operation. 4,000 offshore oil rigs, if they have to be reached for inspection, checking safety, if a disaster, God forbid, happens again, how to reach them quickly. So that's another opportunity. Here in the U.S., we have about 600,000 bridges that are in very poor condition and at risk of collapsing, like we had a few years ago in Minnesota. So there's a lot of opportunities to use this technology and leverage it to things for things that would be of benefit not only for the companies that use it, but for the general public. And for us, we've been doing research on job sites on how to use these technologies to observe workers, track progress, conduct measurements with 3D models and things like this, and these are some of the things that we'll talk about. So what is a drone? What is an unmanned aerial system? So a drone is not only the device that you see there and there. That's not what the unmanned aerial system is. An unmanned aerial system is a combination of things which include the vehicle, the UAV, that's the devices that you see, the operator or the pilot, which in the near future will be known as operator, not pilot. The ground control station, which is, I guess, a fancy way of saying the remote control, or the thing that you use to operate, and the support equipment. So most folks don't think about this. The batteries, extra batteries, chargers, communication devices, tablets, phones, whatever you use to communicate, that is part of the system. This is for what you call a personal UAS. So it's something that I can carry. I can carry in my bag, in one of these bags. You know, it's like open up all over. But so you can carry them around in those bags. But there's others that can be even bigger and more complex, like the ones that we use to perform military operations overseas. So you're probably familiar with those. So what do? Is they go up, you send them into the air, you navigate them around, and you collect data, you collect information. And what data you collect, there's a range of options, and we'll see what those are in a little bit. So the current applications of these systems include the ones, among others, the ones that you see listed here, military. So that's how we first learned about drones. You know, that's what everybody associates with when you say the word drone. They think of this Predator or Reaper or a Global Hawk or some other big bird with weapons. But there are other applications that are beyond military. There's package delivery, which is not active in the U.S. right now. It's being tested overseas. You can use it for collecting information in inspection work. There's also for surveillance. There are unarmed UASs like the military type ones that kind of fly around the border and look at security of the border. There's research, which is some of what we do, and there's agricultural applications where you can inspect crops and see the state of crops that you have. And the traditional photography. Aerial photography, you can take pictures of weddings, buildings, real estate. There's a million uses for picture taking. All right, so what are the different altitudes or elevations that you operate these things at? So usually is the military has 60,000 feet and above. Military, NASA, they do research and they fly at those altitudes. Then a little bit lower than that, between 60 and 18,000, Department of Defense, they fly their equipment, not over U.S. soil. They have a very specific authorization for doing that. Homeland Security flies unarmed drones for border surveillance below 18,000 feet. And the 400 feet and below, or the 0 to 400 feet AGL or above ground level, that's where we could operate. Until a few months ago or a few weeks ago, depending on how you see it, we were restricted to operate at 200 feet AGL. That was changed recently. The FAA provided a blanket authorization for all holders of 333 exemptions and COAs to fly up to 400. So now you can do a little bit higher altitude flying without getting into trouble. But in our experience, 150, 180, less than 200 feet, you can get pretty good results when flying on these devices. So make sure that on the right page here. Yes. So things to remember when you're flying a UAS according to the Federal Aviation Administration, you are a pilot. That is what the regulations say right now. That may change with the impending regulations that are coming. It's going to be known as an operator, not a pilot. So you wouldn't have to meet the requirements for a sports or a private pilot's license, which is what you have to have now. So understand that you have to be responsible because you are a pilot. You are navigating in the NAS or the National Airspace System. So a lot of these rules that the FAA has imposed on us are common sense, and this is something that all pilots follow. So you don't interfere in the path of the aircraft. You don't get in the way. You don't fly close to airports because there's aircraft flying around. So you try to avoid as much as possible interference with other operations in the airspace. And usually the best rule of thumb is when you're not sure if it's safe or legal to fly, then you should stay on the ground. So authorization and legal matters. So there's a few options that you can pursue or someone can pursue to be able to legally fly in NAS using these devices. One is the Certificate of Authorization or COA that applies to the public and government agencies. So that is what we have. Georgia Tech is considered a government entity. I have Georgia Tech's research institutes, ATAS Laboratory COA, which is the one that we operate under. And I'm going to pass it around so you can see an example of what those look like. For civilian commercial operation that is not government, which is all construction companies, all inspection companies, anything that is not government, you are required to obtain a 333 exemption. And for those of you who are not familiar with what that is, so that is basically a request that you make to the FAA to exempt you from meeting that Section 333 of the Federal Code of Regulations that governs the use of aircraft in the national airspace. So you're requesting an exemption from having an aircraft that can safely transport people. And as much as I would try to get on this thing will never lift me up. So you can't transport people on those devices. So you're asking the government to give you a pass on having to meet the requirements of commercial aircraft for these devices, which most people know them as toys too. So that is common sense regulation. The FAA is doing their best and doing it as fast as they can to be able to allow you to use these devices for commercial use that do not include carrying people. And there's a long list of things that they will exempt you from. So UAS manufacturers get what is called a type certificate. We don't have to worry about that unless you're in the business of creating drones or creating things like this. So DJI, 3D robotics, Unique, you name it, whatever manufacturer is coming up with a new one, they have to have one of these to be able to test in the NAS. So these are the categories. So you have category 0, 1, 2, and 3, and these are the weights. That's how the FAA classifies UASs at this time, by weight. So anything that is above a little bit more than half a pound requires registration, regardless of personal or commercial use. So that was the rule that came into effect last December, when there was a big hoo-ha that everybody before Christmas you're going to have to register your drone. Well, that is actually true. Unless your drone is one of the little bitty ones that weighs less than half a pound, then you don't have to do that. But if yours does, like this, then you will have to go to the FAA's website and just pay $5 fee, and they will give you a unique identification number. That number is not for the drone, that number is for you as the operator. So you basically write that number down on a sticker and then you put it somewhere on the device. And all that is meant to do is if you fly where you're not supposed to and hurt someone and you run away and you leave it, somebody can track you down. So that's the safety and security measure. So hopefully that should encourage folks to be more responsible in how they use these things, because there is liability associated with them. Then think about it as I don't know, when you were little, if you played baseball in your neighborhood and you have your baseball, playing the street, and you put your name Mikey, and then you bat and break the neighbor's glass, and then the neighbor can pick up the wall, oh, Mikey, okay, I'll go to Mikey's dad and ask them to fix my glass. So, same thing. That's what they're doing. They're basically labeling their fancy baseball. So, UAS, if it's not class 0, then you need to register before the first flight that you perform. Everybody in our group went through that process. It's very easy. Just go to a website and obtain the number. And if you use a UAS or a drone for personal use, then you use that number. For us, because we use it for research, we have to use the N number. It's a separate registration process that you have to go through to register the actual device. So that's what goes with a COA or a 333 exemption. So your drone has an N number, and it's like an airplane. So that's the difference there. So what is the latest that we know about regulation? So for non-commercial use, this website has had about 425,000 people registered. So that's 425,000 people that could have one or more of this. So I have 2 for my personal use. That's 1. So if I have 2 and everybody else has 2, that's what? About 1 million UASs that could be potentially flying around. But a country as large as ours, you probably won't see swarms of them going around. But that is a lot. So it is a legitimate cause for concern for the FAA to try to manage how these things go up in the air and interfere with air traffic, which they can. Like this model can fly up to a couple thousand feet. So yeah, it could get in the way of an airplane. So 333 exemptions. The latest is that now you can apply for a 333 exemption that covers any platform. This is what the FAA refers to as the UAS's platforms that have been approved. So before, you would have to file your 333 exemption request and indicate which platform you're using. And that's the only thing that you could fly. But now, when you apply for one, then you say, I'm going to fly a DJI Phantom 4, and then tomorrow you buy a 3D robotics Solo. You can fly it if it was approved prior to you requesting the exemption. So that's something recent. In terms of laws, 45 states have considered about 168 bills that deal with the use of drones. So states are trying to regulate how drones are used, what they're used for, where they can be used. We've had a few of those here. And there's actually one waiting for signature of the governor, HB 779, which actually deals more with or trying to avoid weaponization of UASs. So you can't put a gun on one of these things. So that kind of thing. And surveillance, like how police can use it and how they cannot use it. So it's good that they're trying to address those concerns. And there's also the creation of a UAS commission that will try to encourage business in the state and good use of the UAS technology and all those good things. So it's not a bad bill. At first when it started, it was not very good. But now it's not too bad for us in construction, because one of the things that it says is that you're required to get permission of the folks that own the land that you're going to fly in before you fly. Well, guess what? In construction environments, we control the land, we control access, we work with an owner. So it's very easy to get that permission. Not so if you're just flying in your neighborhood and fly over the neighbor's house and want to take pictures of the neighbor's house, you have to ask permission first. So there's some of those things there. So that was on April 4th, it was sent. We'll see when that comes back. 20 states have approved actually 26 bills that deal with these UAS machines. And for the first time last week, the first 333 exemption dealing with nighttime operation was approved. Before that, you can't fly at night legal. You see videos on YouTube at night, those are completely legal, and for some reason the FAA doesn't take action on many of them, but they do. You just don't know. So the first nighttime operation was approved, and it was for inspections of infrastructure, which helps our case. So how is Georgia doing in terms of 333 extensions? This is the latest report from the AUVSI, or the Association of Unmanned Vehicles International. So applications in Georgia approved as of January, there are 84. So 84 333 extensions. Most of them are for aerial photography, which doesn't mean that they don't relate to construction. It's just businesses that want to perform aerial photography, sell their services, and they could be selling them to construction companies. So for construction, it's actually 41. So there are 41 companies in the state that are approved to use UAS in their operations, but that doesn't necessarily mean that they're actually using it. Because one of the issues that many companies have is that they apply for the 333 extension, they get it, but they don't know how to comply with the rules and with all the stipulations, like having a pilot on staff. Most people don't have a pilot on staff. So those are some of the limitations to actually implement 333 extensions. And then the list goes real estate, aerial inspection, aerial survey, which could have something to do with construction. Companies, it was surprising, 39 companies have 84 exemptions, which means that companies have more than one, which is also possible. And they're less than 1 million. So small companies like many of you have probably companies that do more than 1 million, but there's some that maybe do less than 1 million. And they have been able to secure an exemption to do this kind of work. And less than 10 employees. So small companies are the ones that are mainly getting this, and that goes to the chart here. See, aerial photography, that's probably 1 or 2 people. So individuals, basically. So how do we compare to other states? For all uses, our southeastern area, so Alabama, Tennessee, the Carolinas, Florida has the most, and we have 84. So the states surrounding us, other than North Carolina, we're the ones that have the most 333 exemptions right now. For construction-specific applications, we have 41, and all other states other than North Carolina have more than us. So we have quite a bit, except Florida, that for some reason has like 3 or 4 times as many. All right. So what are the top 10 states in extensions approved? Of course, this is related to population and size and all that. California, is the first. They have about 160, and then it goes down, Florida, Texas, Colorado, and we're not on the chart, but we're about 11 o'clock. So we're doing pretty well. We're trying to adopt the technology, not at a higher rate as larger states with larger economies, larger industries, but we're not too far behind to other large states from the data that they have. So that was the radiation. So going back to more the technical aspects of UAS. So UASs can operate at different levels of autonomy. So you can have manual, semi-autonomous, and autonomous. Manual is basically you're flying with control, and you have full control of the craft, and that's how most of these things work, and they are assisted by a range of sensors to make flying easier. Semi-autonomous is when you basically send it up, you have to take off, and you can program some track that the UAS will follow to take pictures, and that's how we do one of the, or how you can do one of the applications, which is 3D mapping. So That's using autopilot and waypoints. And there's fully autonomous that is under development. That's what the Amazon delivery would use. Like they would send the drone and they would just sit in some office hoping and praying that it will come back. Not crash on someone, because to them it'll just be a little blip on a map, like you do your Google Map directions now. So that's the future. Is you send it and it will do its thing and it will come back. That's full autonomy. That is right now illegal in the United States. There are other countries where they're testing it and trying to implement, but not here. Unless you're one of the 6 test sites, which last week NASA tried out their prototype unmanned systems. It's like air traffic control for drones. So they basically had the 6 test sites send out drones, fly them around, and the system would locate each one and tell them, oh, you're going to conflict with one, you need to go down. So it's basically a robotic version of an air traffic control. So that's in the works. So if that progresses, then we'll probably see the autonomous drones become a reality. So, I'm not sure. All right, so going back to the flying. So how do you fly these things? You have to keep them within line of sight. And for everybody to understand what line of sight means, that means that you can actually see this unassisted. This is okay. You can use your glasses, but you can't use binoculars to keep track of it. You have to be able to visually see where it is. There is something called the visual observer, which is a requirement in 333 exemptions and COAs that require you to have somebody else also watching the device. So you can be controlling it and you can glance up and kind of see where it is, but somebody that is not you flying will be able to also confirm where it is, and you usually have communication with a two-way radio. And that is meant to provide perspective. Because if you're flying close to a building and you're looking this way, you can't really determine how close it is unless you use telemetry or some other measurements. But a visual observer at a different angle can tell you, oh, you're getting too close, you need to pull back. This has technology that actually makes that easier. It's called collision avoidance. But that's something relatively new and it's not considered in your 333 exemptions. Then it's also communication line of sight. The link between the controls and the devices is not infinite. So you can't send this 10 miles away and expect to be able to control it. So communication line of sight means that you have to be able to maintain control of the device. These newer versions have features that if you send it too far and it breaks the link, then there's a fail-safe that kicks in and it will send it back to either the home point, and if there's not enough battery, then it will land itself and hopefully will land itself not on top of someone. So that's the communications line of sight. Of a landing airspace, that's the space around airports. And it looks like an upside down cape in many cases because that's how airplanes land. Airplanes do not land vertically, they land at angles. So it starts to descend, 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 and lands. So that's why those are, they have the shape that they have. So then there's class E, which encloses class B, C, and D when the airport tower or the control is closed. Airport control, other than large international airports like Hartsfield-Jackson, are not 24 hours a day. So anything that is not controlled by air traffic control from either the federal government or the airport is class E, which is this. Then you have class G, that's uncontrolled airspace, and that's where you're on your own, you're not monitored, there's no traffic control, and you can fly in class G. So good rule of thumb, some time ago told me, like if you're in class G, you're good, so you can fly. But that doesn't mean that you can go to 14,000 feet or 1,200 or 700. That doesn't mean that. That means that according to FAA regulation, you have to stay within 400 feet, according to your exemption requirements. So there's also special use airspace and restricted airspace. That's military airspace. So don't go flying your drone over Area 51 because you don't shut down. Yes.
Do private property owners own the airspace above their property at some level? They don't.
No, they do not.
Why are we required, we have our tower cranes that boom over other properties to secure easement rights to do so?
Safety. Safety. You're moving a suspended load. So
Also trespassing, going over their property, and they secure a ransom or
Right.
ability to put a tower crane over their property.
oh, so you mean the footprint of the tower crane or just the swing
I'm
radius?
going up in order to move that load, I have to boom over their property. And
Yes.
historically, the builder or the owner has had to pay substantially for the right to boom over that private property.
Right.
They own a certain amount of airspace above their property.
Well, it's not really the airspace. It's the risk of having that thing over their property because either the load of the boom, if it collapses, it will fall on their property. So, like, as far as I'm familiar, I haven't seen those legal situations, I guess. You know more than I do on that topic. But it's my understanding that it wouldn't be the same situation. So look at it this way. A lot of the issues with drones and private property is privacy. So there is the expectation of reasonable expectation of privacy. So if a drone is flying over your house, then your concern is that it has a camera and it's taking pictures of it. But according to the FAA, objects that are flying on the NAS should not give you an reasonable expectation of privacy, because an airplane flies over your house and it could have somebody taking pictures, and that wouldn't apply. So that's where the debate is, and then the worst part is it gets even trickier when you see it, you're concerned, and you take action. And the action that we've heard about is people getting their 12 gauge and shooting it. So the problem is that is illegal, because according to the FAA, if you're flying it under a 333 exemption, or even if let's say you're flying it under 333 exemption. What did we say this was? Considered by the FAA an aircraft.
Yeah.
So you're basically shooting at the equivalent of shooting at a 737 or whatever the denomination is. So you're shooting at a commercial airplane, not really. But that's how the FAA and the law sees it. So the rule is, do not shoot a drone. So if you see a drone over your property, the first thing you do is you dial 911, and the police needs to take care of it. So don't shoot these things, because you're going to get in trouble. Like, people have gotten in trouble for doing that. And it's irresponsible to shoot a gun in here. So, anyway, any questions about the airspace? So the rule right now is, if you're close to an airport, 5 miles or less, and there's apps that will tell you where you are in relation to airport facilities, you should try to stay 5 miles or more. If you are 5 miles or less, and the airport is not a Class B or a Class C facility, then you can call air traffic control or call the airport manager, and you can tell them, I have a project, it's 3.5 miles from your airport, we're going to be flying a drone below 400 feet or below 200 feet. Next Tuesday between 12 and 3, we're giving you notification, and the airport folks would probably not have an issue with that. If they have an issue, then that's a different conversation. But most airports do not. So how do operations work? So operations, what we do and what most people would do if they're using these on a job site that they're working on, there's several stages. The first one is pre-flight planning. So it's like pre-planning for your job. So you have to define where your cranes go, take care of the legal issues, all those things. So when you're using the UAS, you have to figure out where your job site is in relation to airport facilities. You have to figure out where your workers are going to be, because you're not allowed to fly over people, and how close you need to fly to structures and things like that. You have to define where you're going to take off and land at. If those points are not the same, so you have to make sure that the path between them is clear. So there's steps that you take to define the flight path and to define your activities and make sure that you take off and land safely. There's a pre-flight briefing, so we recommended that you get together the folks involved, superintendent, SOS, the PM of the project, and you go over the plan with all of them. So everybody's notified about what is going to happen. Then you set the launch point, you take off, you perform your operation, and then you recover or you land. There's recovery landing because there's two different ways of landing a UAS. And that doesn't mean that there's the right way and the crash. That's not what that means. What that means is that rotary aircraft or rotary devices like this, they have what they call VTLS, vertical takeoff and landing, so they go up and down. Fixed wings, which are like little airplanes, they go up and they usually don't use runway, they use a catapult, so they basically slingshot them up. And then they're recovered because they usually don't use a landing strip, they use a parachute. So they deploy a parachute and they basically fall down, and then you recover them. So you have to pre-plan for all that. And then there's a post-flight assessment. Everybody comes back and evaluates what you got from the data, and make sure that the process was performed safely, evaluates the process, and then improves for the next time if you need to.